Section 10 in Chapter 21 of the Klein's Organic Chemistry textbook talks about preparation of esters. There are three ways to prepare esters. The first way is to take your ester, it doesn't matter, take your carboxylic acid, it doesn't matter what it is, and treat it with a base such as sodium hydroxide. And then treat this with a alkyl halide, say a primary or a secondary alkyl halide. And what you'll make from this is the methyl ester. Okay? Now this reaction mechanism happens by SN2. Let's take a look at the mechanism. In the first step, we have sodium hydroxide that's going to deprotonate the acidic proton here on the carboxylic acid. So this is a deprotonation step. And when you have your carboxylate, that's now a sufficiently good nucleophile to attack a primary or secondary alkyl halide. So we have iodomethane here. And so this is the SN2 step to give you the product. Okay. Now remember, because it's SN2, this only works for primary or secondary alkyl halides. All right. The second way to prepare esters is by something called the Fischer esterification. Now this reaction involves taking a carboxylic acid, adding an alcohol, and in the presence of some acid catalyst, you form the ester. Okay. One way to remember this is that acids require acids. Okay, so this reaction will not work with base, and the reason why is because bases will react with carboxylic acids to give you carboxylates, and this is no longer a good electrophile. You see, a negatively charged nucleophile is not going to attack a molecule that's negative because the like charges repel one another. So let me show you the curved arrow reaction mechanism for this process. Let's look at this reaction here. Let's do acetic acid, ethanol, acid catalyst to make ethyl acetate. Okay. So the first reaction you want to do, once again, when you have acid in your reaction mechanism, you want to use that in the first step. So we're going to protonate, and usually you protonate the carbonyl oxygen. Okay. So we'll protonate that carbonyl oxygen. And now we have a very potent electrophile. It's actually positively charged, right? So our neutral alcohol can now attack that. Okay. We want to attack the carbonyl carbon and move the electrons towards the oxygen. And that's going to give us this famous tetrahedral intermediate. And there's a lot of oxygens here, and it can get kind of confusing what's where and what are we trying to do here. But remember that the goal here is to kick off a leaving group of some kind. And we want to kick off, once again, in the nucleophilic acyl substitution, we want to kick off this group, but we can only kick off water, okay, water. So that's actually a side product here. So what we need to do is a number of protonation and deprotonation steps. First, we want to deprotonate. We have alcohol, right, which is present in the reaction, is right here above the arrow. So I'm going to use an alcohol to deprotonate here. Okay, so now I'm going to protonate this guy here. All right. Now the reason we want to protonate there is to situate ourselves with a good leaving group. Okay, now we have the water poised to be a good leaving group. Okay, so we want to use lone pairs. Okay, either of these two oxygen atoms. I like to use the OH group here, and we'll kick off water. Okay, so under this arrow, I'm just going to write minus H2O to remind myself that water is being expelled in that step. E for elimination, and what we get here is a protonated kind of ester, and so you want to use something that's present in the reaction, ethanol. Or I suppose water, right? Water is being formed in this reaction, and that's going to give you the last step. Okay. So it's acid catalyzed. It's a pad-ped mechanism, so you're going to have several steps: protonation, attack, deprotonation, protonation, elimination, and then deprotonation. Okay, so this is the Fischer esterification. And essentially, there's no limitations on your carboxylic acid or your alcohol. They're going to get together and form an ester, okay? Now, the third way to form an ester is with the use of acid chlorides. So if we have an acid chloride, okay, we could treat this with, ethanol in pyridine to give us ethyl acetate. I'm not going to go through the curved arrow reaction mechanism here because it's in the other video where I talked about reactions of acid chlorides. Okay, so in this chapter there's a lot of going backwards and forwards, and okay, just recall we've talked about this. This is the way to make an ester. Okay, so there's 3 different ways to make esters. Thanks for watching. This is it for this video. Stay tuned for more videos on the Klein Organic Chemistry textbook.